Okay. We are going to do a very quick review of what we did last day because I know there were a few people who are away. I do have a quiz here for Sophie. Audrey's still not here. Okay. So, what I'd like you to do is get yourself a piece of paper. If you don't have paper, there is some at the back in that little basket there. Go get paper now. Okay, your attention in 5, 4, 3, 2, 1. I would like you to see if you can remember the names of the two types of compounds. See if you can remember. If you can, write them down. If not, wait for the reveal. What is one of the types of compounds? Yes, Mateo. Ionic. What is another of the types of compounds, Brooklyn? Covalent. How do we recognize that we have an ionic compound? How do we recognize it? What type of element does it start with? Yes, it starts with a metal. How do I add another one on here? My red pen's gone missing. That's okay. It starts with a metal and this is a new one. Pardon me? Yes. There you go. And this is new, NH4. Okay, so it starts with a metal or NH4. What does covalent start with? Starts with a nonmetal. But not NH4. Okay, because N is a nonmetal, it does not start with NH4. All right, so that's how you tell the two of them apart. Which one uses prefixes? Covalent uses prefixes. Ionic, no prefixes. And could you please write down your prefixes for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to remind yourself of what those are. Hmm? Yes. Usually 1, 2, and 3 aren't too bad. What's 1? Everybody, what's 1? Mono. What's 2? Di. What's 3? Tri. Then we get to number 4, and number 4 is a little weird. Tetra. And if it's helpful, the 2 T's come right after one another. There's tri and then tetra. So T for tri, T for tetra, they come one right after the other. Okay? What do we call a 5-sided figure? Penta, pentagon, penta. And then we have 2 again in a row that start with the same letter. What letter is that they both start with? They both start with? Yes? H. They both start with the letter H. So we have a T and a T. And then we have an H and an H. Six is hexa. 6 has an X and hexa has an X. Now, what is 7? 7's a little weird. It is hepta. And that one you just have to kind of practice enough until you know it. Yeah? I don't know that there's a fantastic way unless you already know heptagon, but the chances of you knowing heptagon are like, I don't know, maybe 25%. So 8 is fairly easy. Octa, because you usually know about an octopus or an octagon. 9, nana. 10, deca. Now, if you choose, when you do quiz number 2 or quiz number 3, if you would like this list, let me know. It will cost you 1 mark on the quiz, so the maximum you can get is a 5 out of 6. So that's for quiz 2 and 3. Now there's a couple special things. Shh. Which one of these prefixes do we only put on the second word? Yeah, mono only on the second word. And then special for oxide and oxygen. What's special about those two? We drop the O and the A. In the prefix. So quiz 1 was all ionic. Quiz 2 is all covalent. Quiz 3 is a mixture of both. Now, what I'm going to do is I'm going to give you a little, this is an extra that's not in your book. This is classifying compounds as ionic or covalent. The answer key is on the back. Okay, so the first thing you're going to do is the classifying compounds handout. Second thing you're going to do is if you have not yet written quiz number 2, you're going to write quiz number 2. Is there anyone who wasn't here? You probably weren't here and didn't write quiz number 1. So you can probably write quiz number 1. Oh, for both of these. Sorry, for both of these, when do we use "I'd"? "I'd" is always on the second word. So for both, "I'd" on the second word. So Elliot, what we'll do is we'll get you a book, we'll get you some practice for quiz 1, and then you can do quiz 1. It's fairly straightforward, and then we'll get you some practice for quiz 2. You'll get caught up fairly quickly. It won't be a big deal. Okay? Would anyone like a printout of these notes? 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to make like 12. All right. Okay. So, folks, you're going to start with this classifying compounds, ionic and covalent. Let's get 1, 2, 3, take one, pass them along, please. I'm just going to grab a tester and Mufasa and I'll be with you. Okay? Who wanted notes here? Anyone who knows? Anyone else notice? Oh, actually, no, it should be. Oh, okay, and I'll write down. Folks, on page 16, you are given the choice of I for ionic, or M for molecular. But I want to let you know, molecular has, hello? This is important. I would not interrupt you if it weren't important. I is for ionic, M is for molecular, which means the same as covalent. It's just another name and you should be familiar with both of them. If you prefer to do a C for covalent, you can totally do that instead of M for molecular. Okay? No problem whatsoever. All right, but do page 16 before you do quiz 3. Make sure you check your answers. If you're not getting them correct, find out why. Ask a friend or ask me. Okay? No, there's something that you and I can do. Like, you can't. I know. Pyro? Celine. If you what? Yes. We will start learning the next thing soon, but not quite yet. Give it 10 minutes maybe.
Quiz, I don't know if it owns anything that I can thing made on my notes.
Okay. Yana, your quiz. Celine, your quiz. Yes.
Did I step on it? Okay.
What is happening? Why is it beeping? Okay.
Okay, is any of that homework?
Anyone what?
Homework?
Homework? What about homework?
Is there
Well, no, you're ahead of things. So if you want to keep working ahead, feel free. Okay?
polyatomic?
Polyatomic ions.
Kind of scary.
Yeah, it is a little bit, but here, hang on. Okay? Yes. Pardon me? When you're ready for quiz 3, you can do quiz 3, yes. Okay.
Wait, you didn't do it. Oh, you retested it? Oh, that's what you did. Wait, eight. All of a sudden. Just like this one. I don't know.
No, you have not. Why don't you do quiz? Quiz 2 is all about covariances. So they're all covariants.
Yo.
Yes.
No, I don't wanna. Exactly. You know, what that is. The art nights because I
That is quiz 3, yes. Spiral. Cairo, your quiz.
Wait, metals have like no prefix?
Yeah, when you have a compound that has a metal, there's never prefixes in that format. Yeah.
Wait, where's my water bottle? Thor, where is it? I want an inventor. I can't.
You said that everything on this side of the staircase is non-metal.
We are going to ignore the metalloids. So, non-metals. Non-metal. Just make them non-metals. Just make your life easy for this
Okay.
unit, okay?
Okay.
Yeah. Yes. Yes.
I get it. I get it.
Well, I gotta mark these things because other people have questions too, right? Hi. Aluminum is a metal, yes, yes. Payton.
Wait, what did I get?
You got. Oh no, hang on. Those are spelling mistakes. Fine. There you go.
That what grade would that be?
I don't know. You can get a calculator and do the division. There you go. Do you know how to do that? Grab a calculator, bring it over here.
Oh yeah.
Hey, can I have my water bottle back?
Caleb.
Wait.
Sit.
What
Okay,
are you doing?
Can I have my water bottle back?
You type in 5.
Yeah.
And then you divide by 6. Very nice.
I see.
So that tells you, and then you move the decimal place over 2 places, that tells you that's 83%. So it is proficient. Nope.
Oh shit, wait.
What can I do for you?
Alright, never mind.
You can check them with. Yes. Angelica. Sora. Sora? So pretty good. Just a couple little things. We don't put mono on the first word, but we do put it on the
Oh wait,
second
so
word.
if it says like nothing, like no numbers.
It's one.
Okay.
And we don't put it on the first word. So this is correct. There's no mono here on the first one word, but we do put it on the second
Okay.
word. Okay. And then if we have an A or an O in front of oxide, we drop that letter.
So it's
Pentoxide instead of pentaoxide. Okay?
Okay, so this is second.
Yeah. So if you want to redo it, you can do 2B or you can move on to quiz number 3. It's up to you.
Quiz three
Quiz
is
3
like
is in there already? Okay, cool. Hi.
yeah,
Okay, it is 1:30, 1:32. Chiral.
Oh wait, this doesn't have big one.
Yes.
You're like almost like the hour of the game.
Bro, it's hot.
Samuel. Phosphoride.
Yeah, I know.
You don't want 3 syllables. Phosphide. Okay? Yeah. Jaden. Yichan.
I believe.
Lucas. Thank you. Thank you, Jim. Lucas. Hi.
Oh, I see a lot of
Okay.
marker.
So phosphoride has 3 syllables. You always want phosphide 2 syllables. Okay?
Oh,
Yeah, and then we need mono in the second word, but not in the first word. So mono, we leave it off the first word.
What's a 70? Is that like a 70?
I don't know. You can go get the calculator and calculate it.
oh, my precious water.
Yuchan. This is really good. I don't know how that I ended up in the middle of your
Oh,
thing. It just
yeah.
appeared
I
there.
don't know how I did good on this one, but not too.
Less prefixes to mess up on.
Yeah.
Yeah.
I did it one
Hey,
time.
you know, last time we did it like 9 times.
Pardon me?
You can go to back.
Well, you know what? You can do it when you need to. I've seen it.
We'll make it up.
I've seen it, June.
Oh, you were you up.
Peyton. Yeah? So carbon, not chlorine, chlorine Cl. And then you need to get rid of these little R's that are appearing in phosphide and things like that. Yeah? Okay, but you know about that now. Okay, cool. Did you manage to finish? Okay, perfect. Thank you so much.
So
You saw what? Oh, your grade? Yes.
it's higher.
Well, it's at 3%, yes?
Oh yeah.
Yeah.
I was estimating like 90.
Ah,
So
did you get 93?
94. So it's like so it's like 3.6% of 5% average. 3.6%.
Okay. Good estimating though.
Go to the next.
So you were only off by 0.6.
No, up 3.6.
Yeah, but there's the extra 3%, which you didn't add in, right?
5 plus more.
What are even my
I'm
grades
so
right now?
confused. What's happening?
So
You thought you would get 90.
I think Maya is either
I
doing
thought
Hmm.
I'll get
whatever she log in from like edges. Maya
something 77 plus something
I think Maya
88
it was probably
plus 290s plus 195.
Oh, it doesn't work that way. Quizzes are only worth 10%.
No, 5 courses.
Oh, 5 courses. Oh, out of all your courses. Okay.
It would do that.
Sorry,
It's
I'm
such
confused.
a animal person.
So
Mm.
average was like this,
Okay.
but now it's like this.
Oh, okay. Wonderful.
I can get another degree for sure.
Nice.
Then I'm going to Hamilton to big snow.
Edmonton?
Yeah.
Mm.
big
Yes.
snow.
Yes. You're going to be a mole person
I'm being
and walk underground from class to class.
hopefully I'm being a chemical engineer.
Cool.
I should have Mr. Wonderful
You should.
if I get it offer.
Yeah. So University of Alberta, which is I assume where you're going, yeah. They have tunnels to get you from class to class so that you don't have to go outside
It
and
sounds
freeze your face.
like so Japan.
So you just have to make sure that you do like look at the sunshine often enough that you don't get depressed. Yes? Yes.
As long as
Go look out the window, stare at the sun. Well, not at the sun,
as
but
long as there's the biggest shopping mall in
Uh-huh.
North America,
oh yeah.
I'll be really happy. And also the what's it called? Costco Business Center.
Mm.
Yeah.
Not today. I just did 10 hours of writing comments over the weekend, so
Yeah.
it'll take a while.
Okay.
Yep.
ICF and ICF on the quiz will stop. Okay, cool. This means I'm genuinely getting the same grade in GM. Same grade as everything.
Grade 9. Grade 9.
Whoa, 3 quizzes in one day.
Well, because they do little quizzes. Little baby quizzes.
Yo, I
do an ionic compound quiz. I do a covalent compound quiz. They do an ionic and covalent compound quiz. Go there.
my calc grade is so evil.
Ah.
Oh, regard. So you know where it is, right?
You know, most of them are great, but I got one girl. She like, she didn't have delusions of grandeur. She wouldn't bother me. But she wants to take enriched science tunes. She can't remember to put add and and we've been doing this for 3 days now. 3 days. And I'm like, and you know what? if that's where her learning is at, I'm okay with that, right? But she's like, I want to take enriched next year. And I'm like, well, you know, you take enriched because you need a challenge. You're finding this course too easy, right? You're taking it because you love learning, right? Which one want to work? Well, what if I get smart? I'm like, what is happening? Like, how is this? What is going on? Right? Like, I'm happy to support you where you are at, but I can't like fix crazy.
Yeah.
Right? Like, I can't fix diluted.
Know your limit.
Like, no, yeah. Damn straight. Damn straight.
Yeah, this is also why I didn't take AP either, right? Because I knew like that workload, like I would have loved it.
Yeah.
But that workload is something you don't want to take on, right?
Right? Right? It's like, do you want to make that much work for yourself?
Yeah.
Right? I understand because, you know, when I was in high school, I had a choice of doing the IB program, which is kind of like it's more, we get all the courses, or staying at my own high school with my friends and not doing it. And I was like, I think I would stay with my friends, not have a crazy workload. Enjoy my senior year.
Exactly.
I'm writing my test today.
Yes, you are.
There's only so much you can put into school. Like, how much can you cost? This is not your life, right? You leave here after
Well,
about 6 hours.
That's the thing, right? Yeah.
Right? And like, I mean, even for me, like, that was a big realization I think this year, especially like towards the end of last year.
Uh-huh.
School is important, like, obviously.
Obviously, yes.
Right? But also, there's a lot of work outside of school you can put into. Like, if just putting in enrich, you can do volunteering, right?
Oh,
You can go
yeah.
out, make extracurricular, and that matters so much more. To universities too. Your friends right about university, university loves it when you have 77 hours, like
Oh, yeah.
700
yeah.
hours on your volunteering schedule.
Oh, yeah, they love it.
Yeah. Oh, I stole a pen from her, but I would have forgotten.
Online. So where's your team? Does it shoot the previous one? Does it? Because like one is that like that's because I was like afterwards. Did they give me credit to it? That was the other. Did I give the credit?
Wait, Abby, I watched an episode of the water bottle in I watched it, but it's still. Just didn't study that psychology.
Yes.
Yes.
No. Okay.
Oh yeah.
Yeah, I just felt it.
Cheap pill. Wait. Have you posted this here?
Yeah, already.
Oh, I have to have it. Dude, we already saw it. What's your grade?
No, okay, not 3%.
Let me see. If you have 93, it's 100 gets to 95.
No, the max area is 100. The max area.
No, wait. So, we have
You just have to buy them all the outside.
no, I don't want to. No more 99. I always have like. Those are worse than 98. 90.
Oh, 99.
You're 90, right?
Yeah.
Wait, what do you mean?
99.
You're 90.
Yeah.
You were 97.
99.9.
Oh, yeah. No, you're back.
Yeah, wrap up the 100.
You were 96. Wait, you were 96.
Yeah, 97.
Okay.
So 99.9.
Oh, so you like add the pounds to 96. You go
96 points.
Oh,
I got 96.9.
I looked.
Actually, what do you think?
Richard. So you forgot. No. You're what? Wait. Oh, wait. What do you
Ravi.
No. You forget you have to. What happened? What about Oh, so you have like I'm like it's here.
No, that's a lie. You only got that for 1 day.
Oh, but it's not in like this week.
No, they have
Can you open your books to 3.1c, please? 3.1c. So we are not going to spend very much time on this because we actually did this in January. Yeah. We did this in January. So we are looking at precipitation reactions, but we are going to go through it really quickly just to make sure we remember everything. So a precipitate is a solid that forms in a double replacement reaction. Okay. And you are responsible for predicting the products, writing the Fe, which is the formula equation. You're responsible for writing the CIE. What does CIE stand for? Complete ionic equation. And the NIE, which is the net ionic equation. What's the difference between the complete and the net? Spectator ions, okay? So just to review what it looks like, You start with two solutions that have dissolved ionic compounds. The ions are free floating. And when you mix them together, do you remember how to predict the products? You take your outside ions and you combine them. You go forward for the outside ions. And then you take your inside ions and go backwards. So you end up with the metal in front of the non-metal. And in this case, we get one precipitate. Precipitate. Be able to write that word and spell it. Okay, how do we abbreviate it? PPT. And that is our solid. What are the NAs and the NO3s? Those are our spectator ions. Now, if we wanted to write the net ionic equation for this reaction, you could write the complete ionic equation and then go to the net ionic equation, or we can use the shortcut. Would we like to learn the shortcut? Yeah. Okay. So to do the shortcut for the net ionic equation, you simply find your solid and you say, I need to have AgCl as my solid at the end. So you put your products first, and then you write your reactants, and you say, what do I need to get AgCl? I need an Ag plus, and I need a Cl minus. That's how you do it shortcut. Then you don't have to do the complete ionic in between, okay? You still should be able to write a complete ionic equation because you might be asked to, but if you want to go straight to the net ionic, if that's what you're asked for, you can do so, okay? So that's a situation where we have one precipitate. We might have a different situation where we have two precipitates, okay? So we go from having free-floating ions, they swap partners, and we end up with two precipitates. What do you notice that we don't have any of here? There are no what's in this beaker? There's no spectator ions. And if there are no spectator ions, what can you say about the complete ionic equation and the net ionic equation? They are the same. So just write the complete ionic equation and then you're done. Okay, if you get two precipitates. Do you remember how to write the complete ionic equation? All you do is you take anything that is aqueous and you split it apart. Okay? So you would take your CuSO4 and you would split it into Cu2 plus SO4 2 minus. Now in this case there's no coefficients, there's no subscripts, so just one of each. Yes, but if you had a 2 in front of this, you would have to make it 2 Cu2 plus. Okay, but we don't have that, so we don't have to worry about it. Okay. We have SrOH2, so we need to split apart the Sr and the OH. So we end up with Sr2 plus aqueous plus how many OHs? 2 OHs because of that one there, okay? 2 OH minus. So anytime you have anything that is aqueous, you split them apart, making sure you use the coefficients and the subscripts to tell you the number of particles. And then, sometimes I have to do it on the second line because it's too long. Our products are both solids, so you will simply write the solids together because they don't come apart. So solids stay together. CuOH2, solid plus Sr, SO4, solid, and that's it. So that's how you would do a complete ionic equation. If this was a case where you had only one precipitate, you would then cancel out your spectator ions to find your net. Yes? It goes to completion because precipitation reactions go to completion. Yes.
But if they were all, none of them all precipitate, they were all aqueous, would it be an equilibrium or no?
A special case, no precipitate. So you see we have free floating ions and we have free floating ions, yes? What do we have at the end? Free floating ions. Was there a chemical reaction? No chemical reaction. What is wrong with this thing? I don't know what happened to my red thing. I've had to replace it. Anyway, there's no chemical reaction. So do we have any kind of an arrow here? No. Should I write these products? No. There's no reaction. So you can just write NR. If you did write the products, you should cross them out. Because you might write the products to find out whether they're aqueous or solid, yes? And you should memorize at least two things that would make predicting that there's no reaction very easy. Okay? And one of those is what ions are always soluble? The metals. Some of the metals. Which ones? The alkali metals.
Some alkaline.
No. Alkali metals are always soluble with everything. What group are the alkali metals? Group 1. Who are the alkali metals? Lithium, sodium, potassium, and more. Really, honestly, these are the three important ones because they are stable, common, not radioactive, yes? The rest of them are just really not as important. So we can say always soluble. Those are our alkali metals. And that's going to be lithium, sodium, potassium. And I mean, you can write cesium and rubidium, but we don't really care about those because they're not very common. Those are the three that you should know for sure. What else is always soluble? NO3. Okay? And there is a third one. Anyone know the third one? It's less important than the first two. NH4+, ammonium. The reason it is less important is that we will be using the alkalis and the nitrates to pair up with other ions to make sure we don't get any side reactions happening. And ammonium can have side reactions because it is an acid. Even though it's soluble with everything, you can have side reactions happen with ammonium because it is an acid. So the two most important ones are the alkali metals and nitrate, but it's also handy to know that ammonium is a always soluble ion. Why is this helpful? Because it allows you to look at this thing and say, I have an alkali and a nitrate. Am I going to have any product? Am I going to have any precipitate? No, because like I've really only got sulfide that would react with something, but there's nothing there for it to react with. Yes? So, just a little review of how to predict the products. You can say, okay, barium is going to get together with sulfate. And copper is going to get together with sulfide. How do you know whether those products are going to be soluble or not? You look at your table of solubilities, and in this particular case, they both end up being solids. Okay? How about this one here? I want you guys to just look at this one, strontium nitrate and KOH. So what we need to do is we need to say we got strontium. No. Nope. You just need to look on your solubility table. These are double replacement. Single replacement, yes, but we're going to replace that with something better this year. We're going to replace it with, the reduction potential table. Yes. Sorry, that took a long time to drag that out of my head. Okay, so KNO3, is KNO3 solid or aqueous? KNO3. KNO3 is aqueous. How do we know it's aqueous? It's got NO3 and it's got K. So we really only need to look at SROH to see if that is soluble or not. And we will go here and we will look and we will say hydroxide, strontium is soluble. So does that form a precipitate? If it's soluble? No. Soluble means it stays aqueous. So we get our product, strontium hydroxide, KNO3. They are both aqueous, so we actually should not write them as products. We should simply write NR, which stands for no reaction. If you did write the products, you can just cross them out. Okay? Actually, can I change this one to a red pen? No, I cannot. How do I change this thing? I don't. Never mind. Okay, we'll go with it for now. So who are the products going to be? Who's one of the products? NH4Cl. And who's the other one? CuPO4. Now you do have to say, what is the charge of this copper? Cu2 plus. And what is the charge of phosphate? PO4 3 minus. So that's going to give you Cu3 PO4 2. Okay? So our products are NH4Cl and Cu3PO42. Out of these two, is there any we can say is aqueous right off the bat? NH4Cl, because NH4 is soluble with everything. If you need to look that up, it's not the end of the earth, but it does slow you down, and you don't want to be slowed down. Okay? Copper phosphate, I happen to know that phosphate is right at the bottom of the solubility table, so it's probably going to be a solid. Let's go take a look, though, and make sure. You don't really need to memorize it, no. But if you get used to the fact that, you know, you've got phosphate down at the bottom, is there anything that it's soluble with? Well, it's soluble with alkalis. It's soluble with hydrogen. Kind of ignore hydrogen for this because remember hydrogens? They're acids. They do their own little thing. Like if you have HPO4, that's not going to dissociate completely because it is a weak acid, right? So they behave differently. Yes, it is soluble, but it's soluble in its molecular form, like together. So just ignore H on this chart. I don't even know why it's on here. Okay? So it's soluble with alkali, H, NH4. Ooh, everything else, it's low solubility. So copper phosphate would be a solid. Okay?
When you say solubility, is it 100% solubility?
As long as you are making, great, if you're making 0.1 molar, you are guaranteed that it's 100% soluble. Now, sodium chloride, which we all know is soluble, can you saturate a solution with sodium chloride? Yes, you can. It takes a while. You have to keep dumping salt in there and stirring and dumping it in and stirring and dumping it in, and it goes on and on and on. But eventually you'll get to a point where it is saturated. Okay? But it takes a while because it has to be like, I don't know, 2 molar or something like that. I don't know. All right. Now for this one, could you write the net ionic equation without writing the complete ionic equation? Let's write it down here. What would we do? We would start by writing our solid over on the right. And then, oh, that's where it is. I have 2 blues. That's why. Okay. I would start by writing the solid on the right, and then what would I need to have on the left? Cu and PO4. How does that look? That would look terrible. What's wrong with it? Charges. What's the charge of the copper? 2 plus. You would have to go back here and say, what was the charge of the copper? It was 2 plus, or you could figure it out from the other one as well. What is the charge of the phosphate? 3 minus. Well, it's less awful. We need our states. Aqueous. And we need our coefficients. What is the coefficient for copper? Coefficient for copper is 3. And the coefficient for phosphate is 2. Okay? So that's how you can go directly to the net ionic equation. How would you write the complete ionic equation for this thing? You would say, here are my aqueous things. I need to split those all apart. How many NH4s would we have? We would have 6 NH4s. Plus, how many PO4s? 2 PO4s. Plus, how many coppers? 3 coppers. 3 times 2 is 6 Cls. And then we have on our right-hand side, we have 6 NH4 plus, and we would also have 6 Cl minus. And then what do we do with our solid? Nothing. Cu3PO4 2 solid, and I forgot my states here and here. And then if you needed to make it a net ionic equation, you would get rid of your spectators. 6 ammonium, 6 ammonium, 6 chloride, 6 chloride, and then you've got your net ionic equation. Okay, that's it. That's all we're going to do with that. Tonight's homework is going to be doing practice with that because you need to be able to write complete and net ionic equations in your sleep. Yes? Forwards, backwards, in your sleep. All right, next, we're going to apply some of that solubility stuff to a technique called qualitative analysis. What happens in qualitative analysis is you are given a solution and you're like, which ions are in here? And you have to add things to figure it out. Okay?
What if it explodes?
It will not explode because ionic reactions do not explode. They just form precipitates. Or water sometimes if they happen to be acids and bases.
So you can basically just do anything.
You can do anything you want here. You might end up with some like poison, but it was poison to start with, right? If you have lead iodide, the lead was still poison when it was just PO2+. Okay? So we have a beaker that contains either calcium nitrate, so maybe it contains Ca2+, or maybe it contains Pb2+, or maybe it contains both. And they all look like clear, colorless solutions, right? It all looks like water. So what we're going to do is we're going to do this qualitative analysis procedure using a method called selective precipitation. And what we do there is we precipitate ions one at a time. So you want to precipitate either the calcium or the lead, but not both. Okay? So you are going to go onto page 4 of your data booklet, and you are going to look for, and it has to be an anion because these are cations. So you're going to look for an anion that will precipitate calcium or lead, but not both. So grab your data booklet if you don't already have it out. If you need one, let me know. I can lend you one. Anyone need one? You need one? So, who's got one? An ion that will precipitate either calcium or lead, but not both. Hayden, where's your data booklet? Then you say this fence. I don't have a data booklet. There's already 2 other people who didn't have one. There you go. Anybody else?
Precipitate calcium or lead, but not both, right?
You want to precipitate calcium or lead, but not both.
Isn't it right there? Chloride, bromide, or iodide?
Oh, is it right there? Chloride, bromide, iodide, what would that precipitate?
Lead.
It would precipitate lead, and calcium would fall up in the all other category, so that would work. So any of those 3. Are there any others that would work?
Not sulfate.
Not sulfate. Why not sulfate?
Because it precipitates both.
Because it precipitates both calcium and lead.
Sulfide.
Sulfide. Does sulfide work? Yeah, because we got calcium up here, and we've got lead down in the all others. Any others? For hydroxide, what would happen with calcium? For hydroxide. Yeah, calcium would fall in the all others, and so would lead. So that's no good, because they would both precipitate. So I couldn't tell whether I had one or the other or both. I'd be like, I got something in there. How about phosphate, carbonate, and sulfite? No, because again, they would precipitate both of them. So that's no good. So we could choose chloride, bromide, iodide, or sulfide. Whoops, that should be a 2 minus. And these will precipitate lead, but not calcium. Is it possible to go into the back room and get a jar of, what kind of ions do you want to pick? Which one? S2 minus? Can we add S2 minus ions all by themselves? No, they have to come with a partner in a compound. And because sulfide is an anion, what does it need to partner up with? It needs to partner up with a spectator cation. Who would be a good cation to act as a spectator? You want a partner that will not take part in the reaction. So do you want something that is going to be low solubility or high solubility? You want high solubility. If you want it to be a spectator, you want it to be soluble with everything. And if it's going to be soluble with everything, who are our choices? H plus, but we don't want to use, don't use acids. Don't use acids for the most part, okay? H plus, who's the other one that's an acid? NH4 plus, and that's because they can react with some of the ions. Like if you're trying to have, if you put H with S2 minus, you'll end up with mostly H2S together, undissociated, right? And we don't want that. And why not NH4? You can most of the time, but it will also produce hydrogen ions in solution, which will then get together with the sulfide. You know what I mean? Right? So it's just better. It's just better to pick the ones that don't react with anything at all ever. So like lithium, sodium, and potassium. Yes, you could choose cesium or rubidium, but let's not go there. All right, because those are weird. And who is the most common of these ions, the one that you find like everywhere? Sodium. Okay? So anytime you need to partner up an anion, partner it up with sodium. So how much of this compound, Na2S, do we need to add? Well, in our next step, what we're going to do is we're going to try precipitating out the calcium. But everything we add that will precipitate calcium will also precipitate with lead. So if we don't get rid of all the lead, we will get a false positive. We could get a false positive for calcium. We could get a solid. Like if I put in sulfate, I'll put in sulfate to precipitate the calcium. The sulfate will also precipitate with any lead that is left over. How do you prevent having any leftover lead? You add an excess amount of the sulfide. And because this is qualitative analysis, you don't need to define how you add an excess, what amount is an excess. You just say an excess of Na2S. This gets rid of all the lead. So we don't get a false positive in the next step. And what this is going to look like is we got our 3 beakers up at the top, yes? So I put in Na2S, I put in some Na2S, I put in some Na2S. If I had calcium, what would I see? What would it look like if I just had calcium ions? Nothing. No precipitate. What if we add Na2S to the lead? We would get a precipitate. And we're going to show the precipitate like this. Okay, what does that actually look like? It looks cloudy. Sometimes it might be opaque, like it might block all the light, but very often it won't be enough solid, it'll just look cloudy, okay? What if we add Na2S and it has both the calcium and the lead? You'll get a precipitate with the lead, and it will look like cloudy. Okay? So you need to, at this point, you are describing a lab procedure, okay? And you need to tell people how to interpret the results. So you will say, if a precipitate forms, what can you tell about the solution? If a precipitate forms, what do you know about the solution? It had PB. If no precipitate forms, what do you know about the solution? No PB. Yes? So you need to, in your procedure that you are writing about, you are going to say, make this statement, if a precipitate forms, PB was present. If no precipitate forms, no PB. Now, in just a minute, we're going to add something to precipitate the calcium. We'll take a moment before we go on to do that. But before we do, let's just say I found an ion to precipitate the calcium. And I wanted to know if there was calcium present. And let's say I added that chemical. If I added that ion that precipitates calcium, what would happen? I would get more solid. What would that look like? Can you tell the difference between that and the first one? If you were looking down while I was doing that, you're going to follow me again while I do it with the second one. We've now added something to precipitate the calcium. Could you tell whether one was more cloudy, less cloudy? Maybe not. So you need to get rid of the cloudy before you precipitate the calcium, the next one. Okay? Because otherwise you're like, I don't know, is it cloudy because it was cloudy before? Is it more cloudy? Like telling degrees of cloudiness is difficult. So we need something. Our solution is cloudy with the PBS. How will we tell if another precipitate is formed? We need to get rid of the cloudiness. In other words, we need to remove the precipitate. Anyone know how to remove a precipitate from a solution? Drink it.
When you said filtering.
You can filter. Now, the only hitch with filtering is that you need a large enough volume, because if you have a small volume and you pour it onto the filter paper, it might just be that your solution just goes into the filter paper and you've used up all the solution, nothing drips through, and you're like, oh, dang, right? So you need a large-ish volume. You need a sufficient volume. Has anyone in here filtered anything? How long does it take? It's boring, yes? You're like, oh my God, are you going to finish dripping already? All right, so it also takes time. Big time. Okay, so although filter is great because we all know what filtering is, and it is a short word to write, so when I'm doing it theoretically, I might choose to say filter. There is a better technique for real life. Anyone know what it is? Centrifuge. And if you centrifuge, you must also, like that'll get all the solid to the bottom. I'll show you a picture of it in a minute. And then once the solid is all at the bottom, you need to pour the liquid off, and pouring the liquid off is called decanting. So you will centrifuge and decant. This is more practical, usually more practical. Okay, so we need to either filter or we need to centrifuge and decant. And we're going to go on to the next page and see what a centrifuge looks like, because we have this lovely picture where it's been chopped in half, and you can see that there are test tubes and they all go out at kind of an angle. Okay, and so you will have in your test tube, you will have the little solid bits floating around in there. Yes? And what will happen is that you will spin this thing really, really fast. And if you spin it really, really fast, what will happen to the solid? The solid is more dense than the liquid. It will separate. The solid is all going to move down to the bottom, and you'll end up with the solid all being like down there and the liquid on top of it. Okay? And what that would look like, I couldn't find a picture of one in a test tube, so we got one in this little, I don't know what you call that. A cuvette? No, not a cuvette. Vial? I don't know. Anyway, same principle. All right, and we end up with the pellet at the bottom. The pellet is the precipitate. In our case, that would be our PB2S, or sorry, not PB2S, PBS. That is our solid. And then up above it, we have the supernatant, which is the remaining solution. Are you going to be asked for the words supernatant and pellet? Probably not, but if you take a university level lab course, you certainly will be expected to know what they are. So there you go. Yes, yes, they use centrifugation for the blood. And now you would need the liquid to be by itself. So what you would do is you would take your liquid and you would pour it off. So this is our remaining liquid, our supernatant. The remaining liquid, which may or may not contain calcium. This thing here is a glass stirring rod. And we pour the liquid down the glass stirring rod. Now, why do we bother with that? Has anyone ever poured something out of a measuring cup into a container, and instead of it going into the container, it goes down the side of the measuring cup and ends up on the counter? Yes. Yes, that's because water has OH groups, right? And glass also has OH groups. So there is hydrogen bonding, a type of intermolecular force between the water and the glass. So it will try and stick to the glass, and that's how you end up with it on the counter. So if you provide a different source of glass, like a glass stirring rod, and you pour it down the glass stirring rod, it will go down there because the intermolecular forces will attract it to the stirring rod. So we pour off the liquid and we leave the solid behind. Okay, and then we have our remaining liquid that may or may not contain the calcium. This process where you pour it off is called decanting, to decant. Or you can filter it. So we have our suspension of the solid in the water or in the solution, and we have our filter paper, and the solid ends up building up on the filter paper. Okay, and that solid is called the residue. Okay, again, you don't need to know that word, but there you are. The liquid drips through. This is our remaining solution, which may or may not contain what happened there? That was crazy. It may or may not contain the calcium ion. Yes? And now we need to say, do we have calcium? Please go find me an ion that will precipitate with calcium. Mm-hmm. We could use sulfate, for sure. Anything else?
Phosphate, carbonate.
We could use phosphate because calcium is in the all others category. We could use carbonate, we could use sulfite. Could we use hydroxide? Yeah, because calcium is in that column. Okay, it's in the low solubility. So we could use any of those. Could we use sulfide? No. Could we use chloride?
Saturate part. Like the CA.
That's the AP rules. Okay, follow these rules for Chem 12.
Sorry.
It's all good, don't worry. Okay, so back to here. So we could use sulfate, hydroxide, phosphate, carbonate, sulfate. Which one do you want to pick? OH. Okay, good. So we're going to pick OH. Can we just say add OH? Add how much? An excess of OH. Are we happy with that? No. What are we missing? OH is an ion. Can we just add it on its own? No, it has to be part of a compound. It needs a partner. Does it need a positive partner or a negative partner? Positive partner. Who is a good positive partner that will not precipitate with anything else? Na. So we don't just want OH, we want NaOH. Okay, so add an excess of NaOH. Yes?
I was wondering about this, but wasn't it also like the reactivity of each,
Those are for single replacement reactions,
not for the whole?
not for double replacement
So
reactions.
that's why CA.
Yeah, yeah. Okay. Now, after we've done that, you need to tell me how to interpret the results. What are the two choices for the results? Either you get precipitate or you get no precipitate. If precipitate, what?
Then CA.
Ca2 plus present. If no precipitate, no Ca2 plus.
What makes you think else? Like it's not CA2 plus, but it reacted with the O2.
Well, we don't have anything like that because no, because if we're giving you a solution like that, it's gonna be like calcium nitrate
Oh, good.
and lead nitrate. Okay, so we're making sure that the ions in that don't mess around. Okay, now we're gonna do the same thing, but we're gonna do it for a mixture of negative ions. Negative ions. This basically just walks you through the whole thing. You need to pair up the OH minus ion with a non-reactive cation. Na is the best choice. So you add an excess of NaOH, and then you make a statement if a precipitate forms, blah, 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 blah. If there are no other cations possible, like if you only had two, a mixture of two, you can just finish here. What if you had a third? What would you have to do? You would either have to centrifuge and decant, or filter. Okay. Do you want to try this one on your own, or do you want to walk through it with me?
Let's do it for homework.
No, because you already have 2 homework questions on this.
We'll do it ourselves.
You'll do it yourselves?
Are you gonna go over it then?
Well, I want to make sure we have time to go over it.
Let's do it with you.
Okay, let's just do it. Hi. Thank you. Can you put that in the inbox, please? Yeah. Choose an ion that will precipitate phosphate or sulfate, but not both. This one's a little trickier, but you have to be okay with understanding what all others means. Phosphate or sulfate, but not both. It's okay, because it won't react with any cations, because all cations that are basic are like, those are strong bases, so it won't react with it, right? Unless it precipitates, in which case that's what we're looking for. Yeah? So we want something that will precipitate either sulfate or phosphate, but not both. Calcium, let's try that. Calcium will precipitate sulfate. Will calcium precipitate with phosphate? Is calcium an alkali ion? Is calcium an alkali ion? No. So calcium goes here. Will calcium precipitate with phosphate? Yes. So it precipitates with sulfate and it precipitates with phosphate. So that is not a good choice because it precipitates with both. We cannot distinguish between them. Feel free to look at your periodic table. Might be helpful. Can we use radium? Why on earth would we use radium?
Who said radium?
Let's argon, a noble gas that does not form ions.
Let's throw in.
Okay, so argon will not react. We cannot use argon. Can we use Mg? So where would Mg be for sulfate? It would be in all others. So Mg is soluble with sulfate. How about Mg with phosphate? Where would it go? Is it an alkali metal? No. Is it H?
No.
Is it NH4? Therefore, it is in the all others. Yes? So it is low solubility. Is that the only one? Only magnesium?
No.
Radium, okay. Can we pick something that's like more common than radium?
Thorium.
Borium? Oh my God. How about, what about beryllium? Does beryllium work? Is beryllium in all others up at the top?
Yes.
Beryllium is in group 2. So yes, it forms ions, 2+ ions. There's weird things. Beryllium is a little weird thing, so we're just going to use it like this. Okay, so beryllium. Is beryllium possible? Yes. How about zinc?
Zinc, copper.
How about zinc? Does zinc work? Yes. Zinc. Copper? Copper, yes. Copper, yes. What are the only ones that don't work?
Alkali ions.
Alkali ions do not work because they will be here. Who else does not work? Silver, calcium, strontium, barium, lead, because silver, calcium, strontium, barium, and lead fall in the all others basket. So silver, calcium, strontium, barium, lead are low solubility with sulfate, and they fall in the all others, so they are low solubility with phosphate. The alkalis are soluble. I meant for that to be a different color. The alkalis are soluble with phosphate, and the alkalis are in the all others, so they're soluble with sulfate. So we cannot use the alkalis because they're soluble with everything, and we cannot use those 5 ions, silver, calcium, strontium, barium, lead, because they are low solubility with all of them. Everything else is good. Uranium, tungsten, iridium, aluminum.
Radium. Radium is so funny, dude. Why did you drop that?
Okay, we could use radium too. I just like not using radioactive elements in my chemistry, but you know. Okay, so we could choose anything except any metal ion the alkalis. Focus, focus. Any metal ion other than the alkalis, silver, calcium, strontium, barium, lead. Yes? So, Yes, we could use zinc. Yes, we could use magnesium. Radium. Beryllium. Iron. Anything, etc., etc. Which one would you like to pick? Gold? AU3 plus. Let's make it very expensive. Okay. So who are we going to pair up with gold? NO3, because NO3 is soluble with everything. The best choice of an unreactive anion is always NO3 minus. So to partner up with the gold, we need NO3 minus, and so we will add how much? An excess of, what's the compound? NO3 3 to the solution. That's solid, that's like neutral gold. This is gold 3 plus. Okay. If a precipitate forms, what was present? Which one did it precipitate? Now you got to go back to your chart and remember. Did it precipitate the phosphate or the sulfate? Go back, look it up. Did the gold precipitate the sulfate or the phosphate? Phosphate. Okay. If a precipitate forms, PO4 3 minus was present. If no precipitate forms, no PO4 3 minus was present. So now we have removed the phosphate. We have precipitated it out. What do you need to do next? We need to get the sulfate, but before we do that, centrifuge and decant. Or filter. Abby, do I need to change your report card to should spend less time doing her makeup in class? No? Okay, then put it away. Excellent. Okay. Centrifuge and decant. What do we do after we centrifuge and decant?
Do it all over again.
Do it all over again. What do? We choose an ion that will precipitate the
S.
sulfate. Go find me one. Water?
What? Just throw in whatever.
Which one would we like? Something that will precipitate sulfate. Calcium, fantastic. You could choose silver, calcium, strontium, barium, lead. Let's choose calcium because we're there. What do we write? Add an excess of calcium, CaNO3 After you've added the salt, what do you need to do next? You need to do your statement. You need to describe how to interpret the results. What do you state? If a precipitate forms,
Sulfate was present. If a precipitate doesn't form, there was sulfate.
yay! Your homework is 3.1 C and page 20. Number 1A and B. I tried really hard. I was like, I can write it down and get to the phone. I can do it. But apparently I could not. Because my internet cable, which is what works the phone as well, is attached to my computer and it cannot do both. Because it's stupid. Okay. I think we can have a quiz on Friday on qualitative solubility. Do you want to do it Thursday? Thursday.
Wait, we have quiz on both. We have quiz on both Thursday and Friday.
If this
We still have a quiz on
test
Saturday.
is on Friday, then I'll have 3 tests in that day. So please.
Monday, I love you.
Yeah, Monday.
Let's send you the bad. Who said Thursday?
Oh, sorry.
Yes, Miss Bell, you're amazing.
Monday is a pro D.
Oh yeah, true.
But, shh, listen. If you have a 3-day weekend and you focus only on 3.1, you will be screwed when it comes to the other stuff. So you need to do 3.1 and 3.2 work over the weekend, which is why I would much rather have it on Friday, because then you can focus on the new stuff over the weekend. What? Thursday? I'll make up my mind by tomorrow.
Let's make it Friday.
I'll make up my mind by tomorrow.
I don't care. Thank you. Thursday have stuff to do.
Not here. No.
Friday also has stuff to do.
Exactly. So
Justin, that's for you.
Oh my god. Get that out of my freaking face.
And I was like, that's not gonna be on test. I think for that. I did 20 practice, and I didn't do any. No, he just dropped you up on your way. That's not my fault. My partner missed 2 days. We had one day.
Sorry for the interruption. Just a reminder to all grade 12 students that you should have sent your capstone presentation to your assigned teacher or due to your assigned teacher on Friday. If you have not yet received your capstone presentation, career center and contact their home.
programming on Wednesday.
Yeah, like watch that.
Eight forty, we got to 8:40.
Wait, you have to you got people in the calendar.
I gotta go, I gotta go. Oh, I'm sorry. So down for that smiles.
Yeah.
Everybody's so sick about everything's day. Oh, like, so you guys can do that? So. Like, if I was.
I will say that I have all my work tomorrow.
Yeah.
I went to walk on Saturday. I hosted it. So there are times.
Oh, when it's all interlocked? Oh, that was really fun. It was kind of like so random. Oh my god, did I throw you? Yeah, I didn't mean to. Oh my god, I don't even know what to do. I feel right. That's the method. So it's like, we're going to go for that. I just took my head, and then I multiple choice, I was like, yeah, this is gonna be good. And I flipped to the right, and I'm like, oh my god, what does that mean? So I'm reading it for like, I don't know, that for like 20 minutes, and I'm like, oh, no. It's just getting worse and worse. Oh well, like, is there actually about this like K, like, you did, yeah, you did it after, that was really good. And I looked at it and they actually changed it. They see that, oh, like, it worked. That's not what that guy did. I was scared, and then I was like, wait, and I was like, and I was like, wait, for 2 minutes. And they were like, wait, I actually don't have, and I was like, wow, wait, actually, I don't. That was just my volubility and first. And then they were all knocked out. Why are we all the way? I don't know what it's called. Who I say? It's the same.
It's like the maximum out of that one.
She's the one there upstairs.
I checked this morning and I was very proud of myself.
Well, it depends where you're at. What are you at?
I'm the 92.
Okay, so let's make that an 89 because that's with the 3%, right? And we're gonna do the math. We're gonna do the math and then we'll put the 3% back on.
Yeah.
Okay, and let's assume you get 89 for the rest of the tests. Okay. So that's going to be times 5 equals, and let's assume you get a 0 on this test, or do you want to? What do you want to assume you got?
What's like the overall? How much the
Multiple
multiple choice were? Because I
choice is 24 marks.
and
Written is 16.
so I'm gonna assume I got like a 60, maybe 50 or 60.
Okay, let's do 50. Okay, just for argument's sake, 50 equals 89 times 5 plus 50 equals divided by 6 equals 82. Okay, and then you add 3, which gives you 85.5, 86. So we'll see.
I can.
That assumes you do as well on the units 4, 5, 6, or 3, 5, 6 as you did on 1 and 2. And they're not the easier units. Yeah?
Yeah.
Oh, bless your heart.
Bye.
Bye.